So in this video we will look into concept like density, specific volume, and specific gravity. Well, start with density. Density normally have a symbol as rho, and density that is equal to mass over volume. So in SI unit, we will have kilogram for mass, volume for meter cube. So the unit for density is kilogram per meter cube. US system will give us pound mass per cubic foot. Okay. Now the next concept will be specific volume. Specific volume was often used in thermodynamics. It has a symbol as small v. Okay, and the definition for that is volume over mass. Therefore, for unit for SI system will be meter cube per kilogram, and US will be feet cube per pound mass. And because of this definition, you realize how density and specific volume is related. They are just reciprocal. So specific volume, small v, is going to be equal to 1 over rho, reciprocal of density. In other words, if you know one, you can find the other. The third concept is specific gravity. Specific gravity, well, we don't have a symbol for that, but we can write as Sg, and that's defined as it's a density of that material over density of water. Okay, and to be specific, it's at 4 degrees Celsius. Okay, we know the density of water is, that's a known value, it's 1000 kilogram per meter cube. Okay, so knowing that, so we know, for example, the density of raw aluminum, let's see, it is 2740, okay, kilogram per meter cube. So can we find the SG, specific gravity? So specific gravity is density of this material that you're interested in over a known material, water density. So that will be equal to 2740 over 1000. That will give us the answer of 2.74. And from this example, you notice the unit canceled out. So the specific gravity has no unit. So it's unitless. Okay. And another discussion, if the density of this material is greater than density of water, then the specific gravity will be greater than 1. Otherwise, the specific gravity will be less than 1, right? Okay. The last concept is called a specific weight. Specific weight is, there's no symbol for that. That's going to be weight over volume. Okay, so it's weight over volume. Then what will be the unit for SI and US? For weight, it's basically how much force is put on, gravitational force put on Earth. So that's a force unit. Weight is a force unit, so that's going to be Newton. Volume is meter cube. So it's Newton per meter cube. US system will be pound force per feet cube. That is our specific weight. And however, specific weight has another expression, and here we're about to derive it. Weight is mass times gravitational coefficient, right? 9.81. And 9.81 meter per second square, that's our G. And mass is our, M is our mass over volume, big V. Now let's think about what is mass over volume. What's our mass over volume, right? It's our density. So in other words, the second expression for the specific weight is going to be rho G. And let's highlight those two expressions. Original weight over volume, or density times gravitational coefficient, rho G. Both of those work. Okay. So let's go look at those four parameters one more time. So they're all related. First one is density. Second one, specific volume. Specific volume is reciprocal of density. And specific gravity is this density over 1000, water density. Okay? And specific weight, the second expression told us it's density times G. So yeah, in other words, if you know the density, you can find all the remaining three. How about the other way around? Can you find, if you were given specific gravity, for example, can you find the density of material? The answer is yes, right? And if you know the density of material, we can find the specific volume. Then we can also use the density times G, we can find a specific weight. So this proves something. Known one, you can find all the other three. Okay. All right. So that's all for this one. And in the next video, we'll do a quick example to reinforce this concept. All right, I'll see you in the next one.